Hi everyone. So as you might know, the path from the point A to point B is not always straightforward. And in this talk, I'd like to share our experience, basically to describe our journey, how we've built a tool, which helps us to motivate people to do migration from one tech stack to another, how we show, how we provide visibility of the process, how we know is it far from the end or not. I'm Alex. I do have Twitter and I do have website and I do have blog with only few posts written, as usual happens with people who build blogs at their spare time. I could actually probably introduce myself in a format which became very popular last week on Twitter, but I won't do that. Yeah, I work for Contentful, and before I started working for Contentful, I worked for Opera. And you know, like many of you know that Opera is a browser built on top of Chromium. And apparently, like a Chromium source code base was the biggest I've ever seen in my life. I've seen a lot because before I worked for a consulting company and I worked for a lot of clients, but like Chromium was something outstanding. So I was trying actually to open the Chromium code base with VS Code, but VS Code, like every time I was opening like a Chromium source code, it became like so slow. It was like barely breathing, right? So I built a tool which actually like I grabbed like variable names and I opened only like a subfolders of the solution. You might tell me that VS Code is a shit and it's like super slow, but it's not about the tool. It's about like the size of the code base I work with. When I moved to Contentful from Opera, of course I had the fresh air because the code base wasn't that big, but like as any like old code base, like 5 years code base or so, like every code base has its own problems, right? And in Contentful, the problem was that they were migrating from Angular 1.x to React, and it has just started. So it was like far away from the end, and because of that, you know, like there were some hacks, and it wasn't clear how to contribute, right? And with my prior experience and the problem when I joined Contentful, I kind of realized that, yeah, it's not always clear, like to understand like where to look for something particular code, or how to understand like is it far away from being migrated, etc. And in Contentful, we had like a migration is not only because we want, right? Because there is a business goal. Do not disturb roadmap, align like a design and front-end teams using component library, increase development velocity and increase quality overall because yeah, React is very good. Yeah, you might ask why to React, but I won't describe because we are at the React meetup right now and we are all biased, we all love React, so I won't explain this. And at the same time, like the complication is that when you do a migration from one technology to another, and you do it on a large scale, I mean like a lot of developers, not only one team. We have around like 20 front-end developers in Contentful and around 7 cross-functional teams. And each teams work on a particular like part of our web app or part of a system, and it's really hard to communicate to each other because like we all fit in different rooms, and it's like the intersection sometimes very small. So the problem statement I faced with, and kind of like I found that the migration from A to B is a complex, and it's not clear when it will be done and how to control this situation on a large scale, as we have in Contentful. So, for example, in our particular, in our specific scenario, we wanted to migrate karma test to just test, right? We wanted to get rid of J templates, which were like used in Angular 1. to React. Also, like as a middle step, at some point, we introduced Hyperscript instead of JSX, and we wanted to move from Hyperscript to JSX and to proper React components. We wanted to use internal component library, which was the people started to build internally and get rid of old like directive and CSS and so on. It's not the whole list. So, and I just got an idea, like, would be actually cool to see like how each particular pull request contributed to migration. So for example, when a person opens pull request, it would be nice to see how these pull requests help to get rid of old technologies. So like imagine like a project as just a set of files, like in this particular example, just JavaScript files. So it would be nice to analyze project automatically and like present data in some digestible way. So we can actually like understand with every pull request, are we moving forward? Are we doing nothing? Or are we getting like situation worse? And like imagine as like a one JavaScript file, as like any of you, as any person has its own characteristics, right? For example, when I look at JavaScript file, I usually like can understand, is it like bad code? Is it good code? Is it like something that you might don't like, for example, like using deprecated React methods, or I don't know, you're inlining style instead of using component library, etc. So when you look at the JavaScript file or any file, you understand if it's good, if it's bad. You can somehow attribute each file in your own head. And the idea was to kind of to try to do it automatically. So we run the tool, and it automatically attributes each file. Is it Angular? Is it React? Is it good? Is it bad? Is it like something that needs to be refactored, or is it all right? So, and the idea, again, was to build it on every pull request being merged to master. So when someone merges pull request, we build this automatically. We kind of recursively analyze the whole project, and we attribute each file with a set of attributes defined in configuration file. So with this idea in mind, I just set like one weekend and build a really like quick first prototype. It is actually like the only like very technical part of the talk. So I just installed a few dependencies. Like first of all, we want to jump between Git revisions. So basically automatically. So check out master, check out previous revision, etc. So I just installed a like simple JIT, the first thing I found on NPM. And also I found a directory tree thing that allows you to recursively call commands for different files in your folder. And yeah, like the basic implementation was just simple git, please give me the last 50 pull requests being merged on master with this simple command. And it kind of like one by one checks out the revision. And for each revision, we run command, it's called build report, which recursively analyzes each folder and attributes each file with a set of attributes. And what is analyzer like in this? What is analyzer in our tool? Basically, just a pure function which accepts like a file as an input and produces an array of tags. For example, I just give it like a pass, and it gives me this file is Angular. It has a directive. It also has React hooks for some reason in this Angular directive, and it uses RxJS. And by looking at this file and this combination of attributes, I can tell, even without looking at code, that something is fishy. So we kind of like wrote several analyzers and compose them into a root analyzer, which recursively build a set of attributes. For example, find explicit library imports. So basically it was reading like imports you have at the very top of your file. Then find Angular usage. For example, find, is it Angular directive being present here? Find component library being used in this file, or find some legacy stuff. And each of these functions, we're actually using like a Babel parser or Babel traverse. It is very similar to how like ESLint plugin works. So basically, they build abstract syntax tree of any given JavaScript file, and then by traversing this tree, it analyzes what is written here, understands its content, and then produce a set of attributes based on the result of the function. It isn't that complicated. So like most of these like analyzers functions are very small, like 50 lines of code or maximum 100 lines of code. And then on top of analyzer, we build the attributor, which is again like a very simple function, which accepts the set of tags or attributes, and then kind of like narrows down these attributes to like a smaller number of attributes, like is it a good, is it a bad, is it Angular, is it React, or is it like needed to be refactored? And basically, yeah, we've built kind of like again logic, like if it's JavaScript file and it has any of the Angular directive or libraries being used, then it's Angular file. If it needs refactoring, it's probably like Angular or Hyperscript or code we don't like, etc. And I call this tool sniffer because it was basically like a sniffing the repository of Contentful, and then published it to private NPM. So we were able to build the history of a project for the last n pull requests being merged, or we actually were able to not only like to build it for last n commits or pull requests, but also like a jump between commits. So for example, like I wanted to build it for last 500 commits, but I was jumping between like 10 pull requests. So I could actually analyze the repository history over the last 2-3 years quite quickly. And yeah, of course, like the tool produced JSON. I was able to understand what is written here, but no one else was able to. So it required some visualization, and not only because it's cool, but just because like it's easier to convince people when you have data presented in a digestible way. And the idea was like, would be cool if we could like see overall migration for each attribute, or for example, see how any particular dependency is being used over time, or see relation between like new and shiny code and old and ugly, right? Yeah, and quickly build like a React using Create React App. I've built a tool which actually was showing like a files progress, for example, like number of React files in our solution or number of Angular files. Also, like for example, in this like on left part of the screen, you see like migration pulse. It's basically like a graph which shows like on any particular day how many like files were migrated. If it's stale for a while, it means like no one contributes to migration and something goes wrong, because overall we know and we understand that it is important for our business. Also, for example, like at the right corner, you see, or left from your, no, right from your side, you see that, like, for example, we were migrating from Karma to Jest, and we also see the relation between Karma tests and Jest tests being written. Also, like as I mentioned at the beginning of my talk, we started building a component library. It's called Forma 36. 36 because our office is located in this 36 district, and the component library is awesome. You should check it out. And the idea was to track adoption of component library as well. For example, like adoption per component. You know, like guys from component library, they produce a new component. They say, hey, you can use it, but are people actually using it or not? And like, and how many components from overall number of components use component library? Because we had like just styles back then, but we want to migrate from it. And let me quickly open a demo. I need to close it. So yeah, we've built a tool, and it shows again like overall adoption of a component library in relation to all files. And now we see like 55% of our components use component library. For example, we can actually see like how many buttons I used over time. And right now, the graph that is represented here, it's like shows approximately like 50 commits being merged to master. But you can, for example, like see how many times like text-link component is used, etc. And the component library team uses it as just some data to reflect on, right? So yeah, and we set it up on a CI to build it for last 50 pull requests merged to master. So like every 2 weeks, we could sit together as a front-end chapter. So basically all people, all front-end developers from different teams, they sit together, they see this graph, and we can kind of reflect on it and see if it goes well or not. Also, this data allowed us to kind of like convince business that if we want have a dedicated effort for the migration, it will take 4 years. Because, you know, we had we've built a data for the last 2 years, used really simple math methods to approximate the graph. And like approximation showed that we'll be done with Angular in 4 years, which is very far below the like a support age. So, and then I kind of like, I built it, I convinced people, we started using it, and then I took a rest, and 6 months later, I went to Paris, and not just to travel, but I went to a Reactor Europe conference, and there was a talk by amazing Paul Armstrong from Twitter. The talk is really good. It is like about how to move fast with confidence as it claims, but it's like a lot of like hints, how to set up a project, like how to set up ESLint properly, how to use hooks. So you can actually like build a project better and reflect on some errors and data faster. But what was the most important for me, it was a tool he showed there. It's called Build Tracker. Actually, it is about like, you know, there's a joke about node modules being really big, but like our bundles, they become big, not because of node modules or JavaScript or ecosystem is bad, but just because we don't pay attention, and it's really hard to pay attention because sometimes, you know, like there is some minor dependency in some minor package just increased, and it brings you a lot of dependencies, and your bundle like 100 kilobytes juicy bigger because you don't know how it happened. So the tool was actually how they track the bundle size in Twitter over time. So they were building, they were analyzing assets that Webpack produces, and they were analyzing these like results over time, and they were building like a graph which showed how the bundles grows, or if the growth is expected or not. Or for example, if you set up a Webpack in an incorrect way, sometimes your chunks or your assets, they produce different hashes. And it means, for example, sometimes, even though like the code in the bundle didn't change, the hash has changed. And it means all your customers who open your web app, they will download this code once again. So this tool, it was showing like the impact on a bundle for each pull request. And it showed like errors when there is no data changed, but there is like a hash change. And I was like, wow, that is something really cool. I want to go back and try. And I went back. And at the same time, I was reading the book called Atomic Habits. It's motivational literature, but it kind of works for me. So, and I enjoyed it. And what I liked the most was about this. It's like a power of tiny gains. So if you get better 1% every day, you'll be 31 something better in a year. But if you just get like 1% worse every day, you'll be just a fraction of what you were last year before. And I was trying like kind of like to apply this thinking to a tool which I've built 6 months ago, and at the same time apply some knowledge I gained from the React Europe conference. So I was pretty pumped and motivated because of the conference and the book all together at the same time, and I decided to sit one more weekend and take it to a next level. Basically, like how to motivate people to contribute to migration, because for 6 months we were building reports retrospectively. It means we do pull requests, we write code, we merge to master, and then we know if it's kind of like affected us in a bad way or in a good way. So I wanted to build an instant feedback using GitHub bots. And I talked to my colleague Mudit, and he decided to help me, which is really nice. Also, we wanted to track bundle size, which Paul Armstrong showed during the conference. And we wanted to build a full project history just to get a better understanding what's going on, not only like last 50 pull requests. So to do that, we needed backend because, like without storing data, it's really hard to build reports for the whole project history and every pull request being merged. So I chose, of course, the very nice tech stack. It's a GraphQL Nexus, which allows you to do like code first schema generation. I used type ORM and PostgreSQL like as a data framework and like for saving data to PostgreSQL, and it was hosted on Heroku. So I don't know if it's small or big. I mean, so the schema, there is a simplified schema produced by this like a backend. So basically we were saving the commit information, like author, branch, like a revision, subject, timestamp. And also like we introduced like a type called project. So we actually potentially can run this tool not for only one project, but for several projects. And there are like several queries and mutations. Basically, I want to query like the whole project history for a given branch, from this date to this date. I want to see like a bundle. I want to compare bundle sizes between this revision and this revision. Or I want to get a migration diff for attributes between this revision and that revision. So how it worked? So basically, developer opens pull request, like Webpack builds, produces some assets, right? And then the tool, it kind of like analyzes assets and sends it to backend and says these assets names and its sizes for this revision of this offer on this branch in this project. And at the same time happens with migration. So it analyzes project, attributes each file with set of attributes, tells is it a bad code, is it a good code, etc. And then the tool, once the reports are built, it compares with the head of master. So with a place from which you created the branch, right? So we have data there, we have data in our pull request, and we can compare it. And the bot tells, no, you're doing it wrong. It's kind of like you introduced like 7 Angular files. Do something with it. Or it tells, hey, you just bumped like one dependency in package.json, but actually it's actually cost plus 100 kilobytes gzipped in our bundle. Please do something with it. Also, I think I will skip this and I will show it in an actual demo because it's like too small. So the pull request looks like, the GitHub comment on pull request looks like this. For example, between 2 revisions, the right part is current pull request, the left part is a master. We see that like this pull request deleted 6 files. 5 of them were JavaScript. 1 of them was Jade, which means it's like an Angular template. It removed 3 tests, and 3 of them were Karma tests, and 2 of them of these files were Angular, and minus 3 files refactoring. Needs refactoring. Probably this particular pull request just removes some feature. It's a really nice example. It's not always like that. And if, like, for example, the pull request shows, like, as one Angular file, for example, this like lovely smile becomes really angry one. And also, like, if you see there is like more details fold at the bottom, and if you unfold it, actually it tells you which files were deleted, and I applied my silly jokes here. But what's more important, it tells you what you could do better in this particular file. You should avoid using following dependencies, right? Because we mark them as bad dependencies. So it's better if you have time to reconsider your decision and maybe make situation better. And the build tracker tool, it also like posts the comment on your pull request. In this particular example, I think we dropped i11 support and removed like a Babel compilation for i11, and resulted with like minus 46 kilobyte gzip in our bundle. And by looking at this, we can actually see, like, for example, like, we know that our bundle is still pretty big, but at least we have a visibility of what's going on. And after introducing this tool, we managed to reduce our bundle size by 0.5 megabyte gzipped, just by having a better visibility of what's going on. Yeah, so kind of worked. Let's wait for a gift to end. Yeah. So, and with all these additions to the tool, actually I show you how it works in practice. So we actually are able to analyze not only kind of like last 2 weeks, but we can actually jump and see, for example, for last 3 months, it pulls data from the backend using GraphQL, which is really cool. We can actually see adoption of component library, or like for the last 3 months. We can see, for example, we managed to reduce the number of Karma files quite, not dramatically, but significantly. We can see that React is the most used dependency in our project, which is really nice. And we can, for example, see that using Lodash dropped over time, which is also nice, because people were overusing Lodash like for map and stuff like that for no reason. Also, for example, like on pull request, we can actually see, I will move a little bit to hide sensitive data. So we can actually see that, like, how many kilobytes we added over the last 3 months, because we add features, we develop something, right? But we also see that, like, yeah, like a lot of Angular was removed, and if we analyze it for the last 6 months, it will be better, and we can actually see that we reduced our bundle. Loading data, it's like a half of PostgreSQL database being downloaded. Yeah, so it's like minus 300 something kilobytes gzipped. And then, for example, we can actually compare build tracker for the last revisions. For example, last revision in master, compare with this one, and we actually see which concrete asset has changed, and in how many percents, and if has changed and or not. So actually kind of analyze how many new JavaScripts our users downloaded. Okay, I'm almost done. So conclusions, what did we learn along this way, right? Yeah, it might be really obvious, but bear with me. Easy access to data helps to increase awareness. First of all, by just providing this data to all developers, and to developers, we kind of like motivated them to contribute more. We managed to reduce our bundle size like significantly, and we are doing it almost every day. By providing this data to business, we actually managed to convince them to give us like several people working full-time on migration, because it's really important for us. And it won't be done without this dedicated effort. Yeah, as I said, like quick automated feedback facilitates good habits. If you see like lovely smiles every time you open APR, you kind of like you feel like your heart become warmer, and you try to do it more often, and it's kind of like helps to build a good culture over time. And the last one is kind of like a negative one: prepare to be in a constant migration. Because what you produce right now, like the new thing that you write right now, will become a legacy of tomorrow. And it's inevitable, because right now, yeah, you know, we're migrating from Angular to React, then we'll be migrating from, I don't know, hooks to some hooks v2 or whatever. And we really doubt that we will sunset this tool, because it actually allows us to track anything, like one approach to another. And it's not about Angular or React, it's just about visibility in general. Thanks.